Hello viewers, today is about logarithm 2, the second aspect of logarithm, and we're starting with the definition of logarithm and then we'll move on to the laws of logarithm. So what we have first is the definition. Definition of logarithm says if log a to base x, log a to base x equals b, then x to power b equals a. This x, which is the base, comes to carry the b as the power, and that's going to be equals to a. So that's the definition of logarithm, and this definition is very important when we are looking at the concept of logarithm, when we are simplifying or evaluating questions in logarithm. So we'll be going through the laws of logarithm. Basically, there are 4 laws of logarithm, but then when we extend these laws, we may be having like 7 to 8 laws of logarithm. So I'll be taking us through the 7 or 8 laws of logarithm in this video. Thank you. So law number 1 says when we have log a to base x plus log b to base x. Seeing that these two different logarithms are having exactly the same base, so we can have it to be log a multiplied by b, and both having same base x. Log a to base x plus log b to base x equals log a times b, both to base x. That's the first law of logarithm. And the second law of logarithm says log a to base x minus log b to base x. So this law says that we can have it to be log open bracket a divided by b, and both to base x, and it can also be written as a log open bracket a over b to base x, which is same as division. So that's the second law. Then the third law of logarithm says this: when we have log a to power b, a raised to power b, and then to base x, what happens? This power comes behind to come and multiply the log. So that becomes b log a to base x. So the power of a comes behind to come and multiply the logarithm. So we have b log a to base x. And then fourthly, log a to base a, that's log of a number to its base, is going to give us 1. Log a to base a is going to give us 1. Alright, so basically these are the 4 laws of logarithm. When you have these 4 laws of logarithm, you can solve any question at all that comes under logarithm. But then when we want to extend these laws of logarithm, we are going to have extra 3 or extra 4, as the case may be, as we'll be having it now. So these are the first 4 laws of logarithm. So by extension, we can be having something like this: log 1 to base x is going to be equals to 0. That is, log 1 to any base, irrespective of whatever the base is going to give us 0. So log 1 to base x is going to be equals to what? 0. But of course, there is an exception to this law. The exception is this: that x itself must not be equals to 0. So that is the 5th law. Now the 6th law is going to be this: log a to base x raised to power b. This time around, is the base that is carrying the power, not the real number. In this case, it was the real number that was carrying the power, and then the b comes behind to come and multiply. But having it here, it is the base that is carrying the power. So what happens when the base is carrying the power? It becomes this 1 over b, not just b, but what? 1 over b to multiply log a to base x. So that's what happens when the base is the one carrying the power. So this is the 6th law. Then the 7th law is this: when we have log a to base, let's say b, log a to base b, what can happen in this case? We can have it to be like this. We can introduce a different base for this number and then the base. And when we have that, when we introduce that different base, we'll have it something like this. That is log a to base x over log b to base x. So what have you seen here in here? Before now, this b represents the base, but then when I introduce an entirely different base that was not even given here, And that's why we could have log a to that base and then log b to the same base. That's why we have log a to base x over log b to base x. So these and these are equivalent. And these one usually come, most cases, most times when we have something like this, when we want to introduce the base 10, log a to base 10 over log b to base 10. So these are the 7 laws of logarithm that we may have or come across at different points in time. These are the 7 laws of logarithm. Now, I want to give us two extra. Okay, and what is it? The first one is this. When we have x raised to power log a to base x. Now you will see that this x here and this base, which is this x, they are exactly the same thing. When you have x raised to power log a to base x, what is it going to give to you? It's just going to give you a as the solution. When you have x raised to power log a to base x, it's going to give you what? A as the solution. And you could have 10 to represent x. 10 raised to power log a to base 10 is going to give you just a directly. That's an application of this particular law. Now, another thing we should take note of is this. What do we take note of? Now, when you are given logarithm, for example, log a ordinarily, there is no base here. You should by default understand that when there is no base to a logarithm, it is assumed to be in base 10. So this log a is the same thing as log a to base 10. And if you are given log 120 ordinarily, no base is given, then it is assumed that this log 120 is to base 10. Those are the things that we say we should take note of. And that is why when you punch in your calculator log 10 ordinarily, it is assumed that this log 10, even though it was not carrying any base, it is assumed to be in base 10. That is why it's going to be log 10 to base 10. And of course, according to one of the laws of logarithm that we have here, when we have the log of a number to same base, what is it going to give to us? 1. So you can see that this is 10 to same base 10, and that's why when you punch log 10 in your calculator, it's just going to give you 1. Alright, so ladies and gentlemen, I give you the laws of logarithm. Thank you.